In this video, I am talking about graphs and how to interpret key features. So we're going to cover things like end behavior, domain and range, maxes and mins, x and y intercepts, just a quick overview of all of the main key features of a graph. So the first thing I'm going to look at are interpreting points. So when you have a closed circle on the graph, or a closed point, that means it includes that point. When it's an open circle, then it excludes that point. So I'll show you a few examples of that, but just keep in mind if it's closed, it's including the number that it's on. If it's open, it's not including the number that it's on. This idea goes back to when we are graphing inequalities. So here's a couple of examples. We have the graph of when x is greater than 3. So that means x is not equal to 3, but it's greater than 3. So it could be really, really close to 3. It could be like 3.1 or even 3.000001. So really, really, really close to 3, but it never actually equals 3. So that's when we have that open circle. And then I have the graph of x is greater than or equal to 3. So in that example, we have the closed circle, and that actually includes 3. So in that case, x can be equal to 3. So here is some notation that we use when we're talking about graphs. So I just talked about the closed circle and the open circle. So all of these different symbols mean the same things. So in the inclusive column, we have the closed circle, or when we're talking about inequalities, we have less than or equal to, or greater than or equal to. And then on the graph, when we write our domain and range, sometimes we'll use these square brackets. So the square bracket means the same thing as the closed circle or the equal to signs. So that means it does include that number. In the other column, the exclusive column, we have the open circle, or we have the less than or greater than signs without the equal to underneath, or we have round, just regular parentheses. So all of those symbols mean the same thing. It means that we are not actually including the number that we're talking about there. I'll give you a few examples so that's a little bit more clear. So here is an example of a graph. So I have this line here. On the left side, we have a closed circle. On the right side, we have an open circle. So if I were to write the domain here, I have a couple of different examples here of how you could write that. So the domain goes from -4 to 5. And you can see here, we have the square bracket on the -4 because that goes with the closed circle here. So it does include the -4, it can equal -4. And then with the 5, we have the parenthesis because of this open circle. So the x value does not actually equal 5. Again, it can get really, really, really close to 5. We could have like 4.99999. So it gets really, really close to 5, but it never actually equals 5. This is just another notation down here where we have this less than or equal to sign. So again, that's because of that closed circle, so x can equal -4. And then here, where we have the less than sign, x is less than 5, so x doesn't actually equal 5, but it's less than 5. Here's another example where we are stating the domain of this graph. So again, on the left side, we have a closed circle at -7. So that means x does equal -7. And then on the right side, we have an open circle at 8. So x does not equal 8. So again, in that first example, we have the square bracket indicating that it is equal to, and then the parenthesis indicates that it does not equal 8. And same thing with those inequality signs. So it is equal to -7, it is not equal to 8. Here's one more example. This time we have the open circle on the left and the closed circle on the right. So again, The open circle is at -3, so we state that with a parenthesis, so it does not include the -3. And then we have a square bracket on the 6 because it does include the 6. And again, with the inequality signs, x is greater than -3, but not equal to it, and then x is less than or equal to 6. Here's an example where both ends have an open circle. So in this case, we would use a parenthesis on both sides. So we have a parenthesis with the -8 and a parenthesis with the 3 because it does not equal either of those. And then in our inequality, we don't have any equal to signs. They are both just less than signs. So x is not equal to those numbers. Here's a graph where we don't have any points on the ends, and instead we have arrows, which means that line just keeps going on forever and ever and ever. So if we're stating the domain, it goes from -infinity to infinity. So when your domain is infinity, it can never actually equal infinity, right? It will just keep going on and on and on and on forever. It can never actually hit infinity. So that is why we use the parenthesis notation and the less than signs with no equal to, because it will never actually equal infinity. It will just keep going on and on and on. It won't stop at infinity. So that's why we use the exclusive notation when we're talking about infinity. Here's a graph where one end goes to -infinity and then the other end stops at 8, and we have that closed circle at 8. So if we're talking about the domain, we go from left to right. So on the left, it goes to -infinity, and again we have a parenthesis there because it will never actually equal infinity. And then on the right side, it goes to 8, and we have the square bracket because of that closed point. So it actually does equal 8. And then we also have the inequality notation. Again, with the infinity, it is not equal to, but on the 8, it is equal to. I already talked a little bit about domain and range, but we'll just dive in a little bit deeper here. So when we talk about domain, we are talking about the x values, and we read the graph from left to right. So all of those previous examples I just showed you, all of those notations were talking about the domain. We didn't look at the range yet, but those previous examples all showed us examples of the domain, reading the graph from left to right, what are the x values. And then the range covers the y values, and we read it from the bottom to the top. So you're looking at what are the y values from the bottom to the top of the graph. Now let's look at a few examples. So here is a graph. If we're looking at the domain, we are going from left to right, and we are looking at the x values. So on the very left, this graph stops at -7, and it has a closed circle, so it is equal to -7. And then on the right, it goes to 8, and it has an open circle, so it does not equal 8. So that's just two different ways that you can state the domain. You can write it either with the parentheses and the brackets, or you can write it as an inequality. But both of those mean the same thing. So we're just saying from left to right, this graph goes from -7 to 8, and x does equal -7, and it does not equal 8. And then the range is looking at the y values. So now we're going from the bottom to the top. So if you go to the very bottom of the graph, that goes down to -5. And again, it is a closed circle, so it does equal -5. And then if we go up to the top of the graph, that goes all the way up to 8. And it has that open circle, so y does not equal 8. And then I did give two examples here in the inequalities, because if you write it in function notation, then instead of y, you would put f of x. But both of those mean the same thing, just the one is in function notation where we have f of x. Here's another example of a graph. So going from left to right, at the very left, it goes to -4 on the x-axis. And then going all the way to the right, it stops at 6. And then again with the closed circle, that's when we use the square bracket and the equal to. And with the open circle is where we use the parenthesis, and we don't have the equal to sign under our inequality. And then the range is going from bottom to top. So now we're looking at the numbers on the y-axis. So at the very bottom, it goes down to -3, and it is equal to -3. And then going up to the top, it goes up to 1, and it does not equal 1. So again, there's those notations there, and then the one is in function notation with the f of x. They both mean the same thing, just one is written in function notation. Now here's an example of a graph where we have infinity, because on the left side we have that arrow, which means it's going to keep on going. And since it's going to the left, if you look at the numbers on the x-axis on the left, they're going into the negatives. So as we go on and on and on and on towards the left, we're going towards negative infinity. And then on the right, it stops at 6, and it has that closed circle at 6. So again, you can never actually equal infinity or negative infinity, so that is why we use the parenthesis, and we don't use the equal to sign with infinity. And then on the right, we have that closed circle, so we'll have the square bracket on the 6, and the equal to sign in the inequality, because x does in fact equal 6. And then looking at the range going from the bottom to the top, so again with that arrow, it's going to keep going down, 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 down to negative infinity on the y-axis, because that's also down where the y values are negative. So it's going to keep going down to negative infinity, and it goes up to the top. At the very top, it stops at 7, and it is equal to 7. So with the negative infinity, again, we have the parenthesis, because it will never actually equal negative infinity. And then on the 7, we have the square bracket, because the y does equal 7. And with the inequalities, again, we do not have the equal to sign with negative infinity, but we do have the equal to sign with the 7. Now we're going to talk about intervals of increasing and decreasing when we look at a graph. So here is an example of a graph, and if you look at the ends, they have arrows, so that's going to keep going to infinity and negative infinity. But when you're talking about increasing and decreasing, this is where you read the graph from left to right. And increasing is where the graph is going up. Decreasing is where the graph is going down. Sometimes it can be confusing. This example is pretty simple, but one thing I used to teach my students that I think they found very helpful, it's a little bit silly, but it is very helpful, is I would tell them to imagine that there's a tiny little man walking on the graph. So he's going to be walking down here, and then when he hits that point down there, then he's going to start walking up. So think about where the little man is walking downhill and where he's walking uphill. So when he's walking downhill, that's where the graph is decreasing. And when he's walking uphill, that's where the graph is increasing. So to state this, you use the same notation that you use like domain and range. And again, you're using the x values. So you're looking at the numbers on the x-axis when you explain from where to where is it increasing and from where to where is it decreasing. So I'll talk about the decreasing first, because that's what's happening first on the graph when we read it from left to right. So first, the guy is going downhill, so the graph is decreasing. And look at from where to where is it decreasing. So because of this arrow here, that's going to go off to negative infinity. So it's decreasing from negative infinity until right here at 1, because that's the turning point. That's where we switch directions. So it's decreasing from negative infinity to 1, and that's why we have this notation here. So from negative infinity to 1, it is decreasing, and this means the same thing here. It's just a different way to write it. And again, with infinity, you never include it because x will never actually equal negative infinity. So we have the parenthesis there. It does equal 1. We didn't have a point here on the graph, but we didn't have a hole either. So we know that it actually does equal 1 at that point. So it goes from negative infinity to 1. That's where it's decreasing. And then 1 is the turning point. So then we would say the graph is increasing here. So it starts increasing at 1, and it keeps on increasing until infinity. So that's when we write increasing from 1 with the square bracket to infinity with the parenthesis. Or we can write it as an inequality. 1 is less than or equal to x is less than infinity. So we are trying to explain where the graph is increasing and where it's decreasing. I like using different colors sometimes, so I'm going to color where it's decreasing. So I'm coloring where it's decreasing in pink, and then I'm coloring where it's increasing in blue. Again, if it's difficult to see that, just imagine there's a little guy walking on the graph and think about where the guy is walking downhill and where he's walking uphill as we read the graph from left to right. So let's look at decreasing first. So this end here had an arrow. So it's decreasing, if we're reading the graph from left to right, it's decreasing from negative infinity to this point here at negative 1. And then there's another section where it's decreasing from 1 here, that's our turning point, decreasing from 1 to infinity. So when you have two different sections of decreasing, that's when we use this symbol in the middle. So we write the first section over here, so it's decreasing from negative infinity to negative 1, and it's also decreasing from 1 to infinity. Again, we are using the x values. So even though this looks like this is pointing down, it is going down on the y-axis, but if you look at the x numbers, it's going to keep going on this way to positive infinity. So that's why we say it's decreasing from 1 to infinity. And then looking at the increasing section, that's just this little section I colored in blue. So it's increasing from negative 1 to 1. So we have the square brackets, negative 1 to 1, or we can write the inequality. It's increasing from negative 1 is less than or equal to x is less than or equal to 1. Here's another example where we're going to identify where the graph is increasing and where it's decreasing. So let me color the increasing first in blue. So here to here it's increasing. Now I'm going to color the decreasing in pink, here and here. Okay, so again we have two different sections that are decreasing. Again, if it's difficult for you, you can picture there's a little guy walking on your graph from left to right. Think about where he's walking downhill and where he's walking uphill. And this graph had points on the end. I kind of covered them, but we did not have arrows on the ends. We had points, and they were closed circles. So this one is decreasing from negative 3 to 0. That's the first section, and then it has another section where it's decreasing from 2 to 4. So this is how we would write that. It's decreasing from negative 3 to 0, and it's also decreasing from 2 to 4. And we have square brackets on everything because they were all closed circles. Or you can also write the inequalities. They both mean the same thing, it's just a different way to write it. And then if we look at the section that is increasing, That starts here at 0, and it increases from 0 to 2. So we would write it like this with the brackets. It's increasing from 0 to 2. Or we can write it with the inequalities. 0 is less than or equal to x is less than or equal to 2. Now I'm going to talk about how to identify the max and min on a graph. So when looking for maxes and mins, we are not including when it goes to infinity. So as you guessed it, the max would be the high point and the min would be the low point. So the max would be right here. That's the highest point besides the end that's going to infinity. So the coordinates of that point are 1, 2. Your x value is 1, your y value is 2. And then the min would be the low point. So right here, and your coordinates are -1, -2. So that is how you identify the max and min. Here's another graph where we can identify the max and min. So we have a max right here at 3, 1, and then the min would be over here at 1, -1. You can see we have another min right here, but it's not the absolute minimum. So if you're trying to find the absolute minimum, then you would look at the lowest point, which would be 1, -1. Now I'm going to talk a little bit about end behavior. So end behavior is what is your graph doing at the ends? Pretty self-explanatory. So here, the ends have arrows. So your end behavior is going to infinity. Also, you can see that they are both going up. So your end behavior will be positive and going up to infinity. Here's another graph that does not go to infinity. So your end behavior is at -3, 1 and 4, -2. Those are the ends where your graph stops. Now I'll talk about x and y intercepts. So x and y intercepts are where the graph crosses the x and y axes. So on this one, let's look at the x's first. So here's our x-axis. So you look at all of the places where the graph crosses the x-axis. So we have one right here, we have one right here, and we have one right here. I don't have the exact numbers on this graph, but let's estimate. So this one looks like it's about, let's see, this would be 1.5 right here. So it's about halfway. So probably about -1.75. And then the y value would be 0 because it's on the x-axis. This one in the middle is at 0, 0. And then this point over here looks to be about 1.75, 0. So those are the x-intercepts. Now if we look at the y-intercepts, that is where it crosses the y-axis. So we just have one point right here in the middle where it crosses at 0, 0. So that would be the y-intercept. And there's only one on this graph. Now on this graph, if we're looking for x and y intercepts, let's look at the x-intercepts first. So again, this is the x-axis here. So we're seeing where does it cross the x-axis? So we have a point right here, and we have a point right here. So this looks to be about 0.5, 0. And then this one would be 2, 0. So those are your x-intercepts. And then looking for the y-intercepts, it looks like we just have one. It looks like it crosses about here. So that would be about 0 and 2.5. And that would be the y-intercept. Now I'm going to talk about finding f of x and x. So x would be the x value, and then f of x would be the y value. So you might get a question that says something like, when x equals 0, f of x equals, and then they'll have a question mark. So you look on your graph when x is 0, and then find what is the y value there. So x is 0 right here, and this one just happens to pass through the origin, so then we would say when x is 0, f of x equals 0, because the y value is 0 at that point. Then you might get a question that says, when x equals 1, f of x equals what? So we find where x is 1 right here, and we find where that point is on the graph, which would be right here. So when x is equal to 1, then f of x, or y, is equal to 2, because of this 2 right here. It can also go the other way around. You might get a question that says, when f of x equals -2, x equals what? So then you're looking for when y is -2 on the graph, so that would be down here, and we find where that is on the graph. So we actually have 2 of these. We have a point here, and we have a point here. So when f of x equals -2, then x equals, we have a -1, and we also have a 2, because it's -1 right here, and it's 2 right here. So that's just finding the values of x and y when you're given one or the other. And remember, f of x is your y value. Here's another example. So you might get a question that says, when x equals 1, f of x equals what? So you would look at your graph, find where x is 1 right here, and on the graph that point would be right here. So then your y value when x is 1 would be here at -1. So you would say f of x equals -1. And then let's do another one. When x equals 3, f of x equals what? So find where x is 3 right here. So on the graph, I'm just going to pretend it hits that line. It's not exact, but let's just say it is. So then we would say f of x, or our y value, would be 1. So when x is 3, then f of x is 1. So there's just a couple examples of how to identify x and f of x on a graph. And that concludes this video. That was just a brief overview of key features of a graph, how to identify x and y intercepts, maxes and mins, domain and range, and behavior. Just a few different things that are key features of a graph. I hope you found this helpful, and if you liked it, please like this video and subscribe, and please let me know in the comments if you still have any questions about this, or if there are any other math topics that you would like me to cover in a future video. Thanks for watching.